Everything's gonna be all right. Nothing. Yeah.
Good afternoon, students. I'm going to try to test my speaker. Okay. All right, that's working. All right. I see everybody's here. Very good. Can you guys hear me? Hi, Jenna. Okay, good. Very nice. Let me keep going down the list here. Ooh, somebody mysterious, the letter J. Who is that? Hi, Steve. Here's Yaz. Okay, hi, Yaz. I'm going to promote you to co-host. Okay, so you can use your mic whenever you want. And is Anna in here yet? Okay, Anna, let me promote you to co-host. Okay. Okay, good. Welcome. Let me go to the Keynote file and let's share that. And welcome everybody. What we're going to do today is just a few things. I'm going to take a look at the emergency YouTube diversion page again, and then we'll talk about the final exam for a few minutes. I'm sure you all have questions about it. It's getting up there a week from today, the 21st. And so this time a week from now, you guys will be blazing through your final exam. Some of you will probably be finished with it already. So we'll talk about that. And then I want to talk about problem 3 from homework 18 and give you guys some extra practice with that for today. And Thursday, we'll talk some more about homework, et cetera, and get you ready for try to get you ready for the final. Okay, so here's the emergency. Anna, can you see the emergency YouTube diversion page now?
Yes, I can.
Okay, great. So here's the top, and then down here's the bottom. And so where we are is today is right here. If we were still in the psych building, room 108, we'd be having regular lecture 27. And your substitute is the recycled lecture from last spring. So that'll be in this YouTube link. And after doing that, you can try homework 19. Now, I think some of you have already tried homework 19, so that's good. But what we'll do is on Thursday, the 28th meeting of the year, we'll go over some stuff from homework 19. So give homework 19 a good shot. And if you get tripped up on something between now and Thursday, be ready to ask a question, okay? Or post a new question thread in discussions. That'll help too, which some of you have done. Okay, by Thursday this week, you'll want to be finishing up with the regular lectures for the semester. So that's lecture 28 on the periodic table. And let me remind you that the textbook kind of runs out before I get to the periodic table part. I'm still in the process of writing those. So that being the case, just keep it simple and stick to the stuff that I talk about in lecture 27 and lecture 28. All right. In other words, let lecture 27 and lecture 28 be your textbook for the very last part of this semester. After lecture 28, you'll want to start working on the bonus assignment, the mega review. And that's due at 8 o'clock, right before the final exam becomes available. The other two are due the night before that at 11:59 p.m. So regular homework 18 and 19, get those done next Monday night, if not sooner, and then get the mega review done overnight, if not sooner, and you'll be good. And hopefully you'll. Now, what I do with the bonus point activity of that kind, I'll take your score. I think there's 22 points possible, and what I will do is scale that down to 4 bonus points, or depending on your score, 2 bonus points, 1 bonus point, 3, whatever it works out to be for you. All right, now let's talk about the final exam. And April 21st, that's next Tuesday. It'll be available at 8 o'clock in the morning. And you have to get it submitted by 11:59 p.m. All right, it's 100 points and basically double the size of a midterm. And so just think midterm exam 3 times 2, double that. It's mandatory, so you have to be there. All right. And since you have a lot of flexibility with when you take it, between 8 o'clock and 11:59 p.m., you've just got it. There's no substitute. You have to take it. Okay. You can't take it early and you can't take it late. All right. Alternative, if you ask for it for late, early, or anything like that, I'll turn you down. I won't. I don't permit that. So you gotta hit this. So what that means is if you have a job and stuff, you're gonna have to block out some time on Tuesday. Right now, on the regular semester, without a remote control emergency like we're on right now, you would be obliged to do that for the final at the normal time, which for us it was 1 o'clock to 3:50. All right. So for me asking you to block out a 2 hours and 50 minutes of time on the 21st for an online section, that should be no problem, because you should have been thinking about that since the beginning of the semester. All right, because that's in a normal semester, you just got to be there for the final. Same thing here. You just have a little bit more flexibility. So what you'll do, you'll get a 170-minute block of time. And so that means you can start at 8 o'clock, 11:30 before lunch, or take a nap after lunch and start it at 2:30, or 5:30 p.m. or 4:45 or any time. And if you want all 170 minutes, you've got to start by 9:09 p.m. because it has to be submitted at 11:59 p.m. So if you started at 9:10 p.m., you won't get all 170 minutes, right? You'll be shaving every minute that you delay after 9:09 p.m. You'll be shaving off a minute from the amount of time that you have. And you can drop a minute or two, but most people will want all the time that they can get. All right. And it's going to be one test. There won't be a bonus, optional bonus mini test like there was on exam 3. So now let me pause for questions, and you guys can go ahead and type something in on the chat screen if you like. And let me. So questions about the final. I just went over that, Lauren. It's double the size of a midterm, but you actually get 2 hours and 50 minutes to take it. Okay. So that's 170 minutes. Correct, Sophia. Another question. Question, is the mega review mostly what is on the exam? No, it is not. The mega review is a study tool. So you're going to have completely different stuff on the final. So it's not like it's not like I see some instructors in some institutions do, where they give you a study guide and then the study guide is the actual test. That's not it at all. All right. However, it will help you to get ready, and hopefully it will inspire to study and dig through your notes and listen to the YouTubes and stuff like that. We'll be going over that before the exam. No, you will not. I won't be, but you can if you use discussions. All right. So, and that's a good way to use discussions. Okay. All right. How does that sound, Katie Winchester? Does that answer your question? Okay, good. Okay, Dana. Yeah, it is cumulative. So everything since the beginning of January when we started the semester. Always. More questions? Is that clear, Dana? Okay, great. All right, another question from the students. Yes, let's take a minute here. Do you want to say anything about study union, etc.?
Sure, I have I guess a mini announcement. Still, unfortunately, they haven't given me the exact day and time. They haven't confirmed it, but it's gonna be. I'm assuming it's gonna be on Monday, obviously, right before the exam. I'm not sure if it's morning or evening though, but even if students can attend, it's gonna be recorded and it's gonna be uploaded to a WordPress page. The link to view it. And then I have some materials already up on that page, but I'll send out one of those announcements. To the
Okay, great. All right, well, let me know as soon as you can, as soon as you have the schedule, and then I'll put an announcement in web courses, and so everybody can see that. Anna, do you have any comments that you'd like to share or tips?
I would say when I was studying for your final, I just rewatched all the lectures and I felt like that really helped me. But also, a lot of people have been sending me private messages on web courses, and I do respond to those within 24 hours. So if you're having trouble doing math on any problems, you can definitely send me your math and then I can review it with you. Since, on discussion, we don't want people posting answers to problems.
Right, that's true. Okay, good. And thank you for contributing. Except this morning you said some mysterious acronym that I'm embarrassed as an old math teacher. I didn't recognize what you were talking about.
Oh, PEMDAS. Is the person here who had a problem with that?
Yeah, I know. I figured it out later. It's powers, exponents, multiplication and division, addition and subtraction.
The first
order of
I think
completing operations.
Yeah, it's just order of operations, because that one problem you have posted definitely has a lot of different steps, but you want to be careful to make sure you're doing them in the right order, or else you're going to get the wrong answer.
And guess what? We're going to go over one right now. So let's go over to, hold on a second. Let me go over to this. Let's go to, let's try the calculator for a second. Okay, can you guys see my calculator at all?
No, I don't think we can see it.
Okay. Boy, where's my Zoom page? Here we go. Let me do a new share. Okay, let's see if I can go back to Keynote. Here we go. Okay, can you see my Keynote file now? the emergency YouTube diversion page. Can you see that? Yes, no, or maybe. Okay, you can see it. Okay, great. So here's the, the blurb that we just went through. Okay, now I want to talk about the problem number 3 in homework 18. Here's an instance of it. Now, before class, I double checked. And in this particular problem on the mythical element Chucktanium, the one variable that changes is n. So we're trying to figure out the wavelength to the nearest nanometer, and we are given a specific value of n. Now there's several values of n that you can use here, and when you do this problem more than once, you might get n equals 9, n equals 7, n equals 6, and I came up with n equals 5. So let's solve the n equals 5 version. And for practice, when you're doing this, we're just going to go step by step, and definitely type in questions in chat, and we'll take a look at them as we go. All right. So here's the Norris Series formula. It looks like the Balmer formula, 1 over lambda. So it's a formula for which the pattern is most apparent in inverse wavelength, 1 over lambda. The Rydberg constant, R subscript CH for Chucktanium. And then the brackets, 1 over 3 squared minus 1 over n squared. Now, we have n equals 5, so that transforms into this version, 1 over lambda equals, okay, the Rydberg constant for Chucktanium, 2.042 times 10 to the 7, and meters to the minus 1. Now, meters to the minus 1, that means inverse meters, okay, because we have a formula for 1 over lambda, inverse wavelength. So my units, nothing else has units, only the Rydberg constant. So it's inverse meters, and that's consistent with what it should be. Now, with 1 over 3 squared, that's replaced by 1 over 9, and then the subtraction sign. And then 1 over n squared. Now, we have n equals 5, so 1 over n squared is 1 over 5 squared, or 1 over 25. So far, so good? Tell me yes, no, or maybe. Okay. All right, good. Good. So that's the first step. That's like the plug-in step. All right. We're plugging in n equals 5 quantity squared down in the denominator of that second fraction. Now, it's fractions, so we got to deal with common denominators. And for this one, there's only one common denominator. Well, the easiest one is 225, which is 9 times 25. So that's fairly easy to figure out. But then you have to make the numerators proportional. So instead of 1/9, you have down here 25 over 225. That's the same as 1/9. Now, don't reduce it. I mean, normally you would want to reduce it to 1 over 9, but we're going to try to subtract them and then use that fraction, right? Can you guys see my cursor, or like a little dot or something? Okay. So this is 1/9 right here, 25 over 225. Now, 1 over 25 is 9 over 225. Right? And again, if you put that in on your calculator, it'll reduce to 1 over 25 or 0.04 if you actually calculate it out. Okay, but we're not going to reduce them until we subtract them. All right. Now, this 2.042 times 10 to the 7 over here, inverse meters, I'm not doing anything with that. Not yet. I mean, I will, but not quite yet. I want to deal with these disaster fractions over here. All right. So the next move is to say, all right, 25 minus 9 is 16. So my my quotient is simplified to 16 over 225. Now, we can't cancel out anything there because it's they don't reduce. Okay, so you just got to let that one stand. But that's all right. We can calculate with that. All right. Now, anybody have a question up until this last equation? All right. Let's continue. Now, I'm just going to repeat this bottom equation with a 16 over 225 at the top of the next slide. So here it is. All right. Now, we've got to deal with that 16, the 225 in the denominator, and the 2.042 times 10 to the 7 inverse meters. All right. And so what I did was I just put my 16, you know, I parked it over in front of the 2.042 times 10 to the 7 inverse meters. And then I left my 225 down there in the denominator. And that's just me, you know, that's the way I would do it. If I were doing it out on a chalkboard or something, I just try to make it a little bit more conducive. Okay. Now, the thing about this is the inverse wavelength. Now we want lambda. We don't want 1 over lambda. So if you get to this point, you're good, but you still have to flip-flop. All right. So if you flip-flop this expression, you'll have an expression for lambda over 1, or just lambda. All right. So let's flip-flop it. Okay. And now 225 is flip-flopped up to the top. The 16 and the Rydberg constant are down the bottom. All right, and we can handle that. And one way to handle it is to recognize, okay, the 10 to the 7, 10 to the regular 7 in the denominator is the same as 10 to the minus 7 in the numerator. Meters to the minus 1 in the denominator is the same as meters to the regular 1 in the numerator. So here's what I've got. Okay, I've got 10 to the minus 7 meters up on top. And then this business of 16 times 2.042, that works out to 32.672, right? And I still have my 225 up on top, all right? Does everybody agree that this makes sense? Type in yes, no, or maybe. Okay, Maria. Okay, Eliza, Ashley, good. Okay, Andrew, good. Good. All right, so far so good. Now this is now an expression for lambda, the wavelength, which we're trying to figure out. It's gonna be a certain number of meters or nanometers, and we're supposed to look for a whole number of nanometers. All right, now we don't have nanometers yet, and we still have that quotient to do. So let's do that quotient. All right, that's gonna be about 6, somewhere between 6 and 7. You know, because 32 times 6 would be what, 190. That'd be 32 times 6 would be 180 plus 12, so that'd be 192. All right, so this could be a little bit bigger than 6. All right, so here's your calculation. And if you calculate that out, it comes out to 6.887 times 10 to the minus 7. Anybody verify me on that? Type in yes, I verify if you verify. Okay. Okay, good. One verification. You know, I love being in class with you guys because I can see your faces and I can see your hands go up and stuff. And I can't really do that here because, aha, Sophia. But you know, it helps me in class, not just to see you guys raise your hand up, but also to see the look on your face. And I mean that in a really good way because it encourages me to see your face, especially if you're if you have an expression that means that you've comprehended, you know, the question, that you kind of have confidence. I can't see that here digitally. So, I mean, there's no replacement for, you know, for a regular classroom, in my opinion. Anyway, so here's what we got. You guys, a lot of you guys verified, so that's good. 6.887 times 10 to the minus 7. Now, that's not nanometers yet. It's a little bit bigger than a nanometer. So what we're going to do is we're going to mess with the exponents and the decimal points. All right, so we're going to move the decimal point to the right and increase the exponent in the power of 10. All right, so there's my first move. 68.87 times 10 to the minus 8. All right, now that's completely equal. All right, but that's not a nanometer. A nanometer is 10 to the minus 9 meters. Oh, and by the way, I'll be able to give you on the final a little table. I don't know if I did it on exam 3. I think I might have a little table of all the prefixes and stuff, nano, mega, giga, and all that stuff. So you don't have to worry about memorizing that stuff. So what we're looking for here is, yeah, Katie, I'd much rather be in class. Well, we just gotta, hopefully fall semester, we'll be back to normal. All right, and then we can, you know, you can come and see me at my lecture if you want, just to check in. Anyways, we want to get 10 to the minus 9 meters. And we're almost there. We got one more step. And here we go, 688.9. Actually, that should be 688.7 now that I look at it. And I won't be able to change that. So when you're looking at this in YouTube, make sure you write down 688.7. That is a typo. All right, so now I've got nanometers, all right? Oh, Andrew, thank you. Yeah, cross that out and put in a 7. Good. All right, I don't know how you do that anyways. So now we're looking good. We've got 6088.7. So that to the nearest nanometer, that would be 689 nanometers. Right, so there's lambda. All right, now my wife's making a smoothie. Hold on. We just made a. Are you done? Okay. Yeah, we're just making a smoothie. We just got back from Costco. So 688.7 to the nearest whole number of nanometers, 689. Now, anybody have a question from this page? Because I want to just make sure we go nice and slow, step by step. And if anybody verify me on 689 nanometers. Bueller? Anyone? Okay, good. Good. All right, so you guys are verifying. All right, now, let me just go to the next page. And here is the page in which I typed in my answer. So I typed in 689 down here. And of course, up here to the upper right, you can see that I got it correct, 3 out of 3. So that's pretty good. All right. Now, we're done. It's a little bit past 2, so we're good for time. And let me just stop the keynote file. And before we go, let me just make sure to encourage you, get all your homework done this week. all right? Because, you know, the final is coming up. It's going to be fast, fast, fast. It's going to be amazing. All right. It's about the earliest I've had a midterm in many a year. So, you know, just get your homework done, and I'll see you guys on Thursday. See you later, alligator. See you in a while, crocodile.